This is Chapter 11, Subqueries. The objectives of this lecture is that at the end of this learning segment, you'll be able to describe situations in which a subquery provides the optimal solution to a question, define the three SQL standard subqueries, which is row, table, and scalar, and explain when to use all, any, and some. The significant points are that there's always more than one way to solve any given problem in SQL. And when building complex filters, you do not have to rely on the tables in your from clause. Using a subquery in a where clause is the only way to get the correct number of records in the answer when you want records from one table based on the filter contents from other related tables. Why would you use a subquery? What is a subquery? A select statement expression that you embed inside one of the clauses of a select statement to form your final query statement. Three types of subqueries are row queries, table query, and scalar subquery. What is a subquery? It's a select statement expression that you embed inside one of the clauses of a select statement to form your final query statement. The three types of subqueries are row subquery, table subquery, and scalar subquery. A row subquery is an embedded select expression that returns more than one column and no more than one row. You use a row subquery to create the SQL standard row value constructor. It allows a search condition that compares multiple values as a logical row with another set of values as a logical row. Two row value constructors. Table subqueries. You've already been using table subqueries. What's new is the in predicate. And to have a refresher, check out Chapter 6 of the book. Scalar subqueries allow a single column or calculated expression from another table that does not have to be in the from clause or the main query. You can use the single value assessed by a scalar subquery in the list of columns requested in a select clause or as a comparison value in a where clause. Subqueries as column expressions. You would use expressions to generate calculated columns to be output by a query. You can also use a special type of select statement, a subquery, to fetch data from another table, even if the table isn't in your from clause. So with this, the select expression appears in the syntax diagram for a value expression, which means that you can embed a scalar subquery in the list of expressions immediately following the select keyword. A scalar subquery is a select expression that returns exactly one column and no more than one row. This is used when you're substituting the query where you would normally enter a single column name or expression that results in a single column. A subquery used this way allows a single value from some table or query to be included in the output of the query. No need to reference the table or query that is the source of the data in the from clause of the subquery at all in the from clause of the outer query. In most examples, you'll need to add criteria in the where clause of the subquery to make certain it returns no more than one row. Here are a couple of examples of two ways to do the same thing. The first one is using a subquery. So we're going to pull these rows from the select subquery. And actually the subquery runs first. So it's going to select customer last name from customer, where customer ID in the customer table equals customer ID in the orders table. After it has all of the last names, then it's going to pull out only the dates that are 2007-10-03, and it's going to pull these rows associated with this where. And the way we've done it in the weeks past is using an inner join, and you would select order number, order date, ship date, customer last name from customer, inner join orders on customer ID in both tables, where ship date equals 2007-10-03. And using aggregate functions, the count and the max aggregate functions. Aggregate functions are any function that calculate values in a query. For the count aggregate function, determines the number of rows or non-null values in a result set. It's count with parentheses around whatever you're going to count to find how many rows are in an entire set. And then the max aggregate function determines the highest or most recent value from any related table. Here's a couple of examples, one using the count and one using the max aggregate function. This first one is going to pull, well, first we know that it's going to run what's inside the parentheses, which is the subquery. So it's going to select all, it's going to count all of the orders where customer ID equals customer ID in the order table and the customer table. And it's going to call that as, it's going to call that count of orders. And you can see that the count of orders is a row because we're calling this group of data count of orders. And then it's going to go in and find the customer first and last name and put the number of orders that that person has submitted. For max, we're going to select the maximum order date from orders, and we're going to call that last order date, and it's going to pull the last date that each customer placed an order. Subqueries as filters. A comparison to a value returned from a subquery. So this filter example, we're going to find all of the customers, their order number, their order date, the product number, product name, and the quantity ordered. So we're going to select those items from customers, inner join orders on customer ID in both tables, orders inner join details on order number in both tables, and order details inner join products on product number in both tables. And then our where statement has where order number or order date equals, and then here's our subquery, which is select max order date from orders as O2, where O2 customer ID equals C customer ID. Now the O2 here is because we've already defined O up here, and we're going to do a comparison on itself. So we have to name the table, the alias, something different. So we're just going to do 02. And you can see that our results are the last order date for each order. And this just shows one person, but the results were actually considerably longer. I just couldn't fit all of them in this screenshot. Special predicate keywords for subqueries. There's in, which is any value in the in list, could be a scalar subquery. However, avoid embedding in clauses within in clauses because it makes the query harder to read. And all is the comparison must be true for all values to be returned from the subquery. There's also some, any, and exists. So let's take a look at an any, equal any in a subquery. So we're going to select the recipe title from recipes, where recipe ID in, and we're going to put our select statement after the in. Select recipe ID from recipe ingredients, where ingredient ID equals any, and so it has to find all of the ingredients beef or garlic, and then it's going to pull the recipe ingredients and then the recipe title. So we're getting a recipe titles where the ingredient name is either beef or garlic. And here we're using the greater than all. So we're wanting to find out if first all of the categories that are clothing have clothing as the description, and we're pulling the retail price. So there happens to be only 4 of those, and so here we have the retail price that we get from the subquery. And then because we're using the all has to match with the category accessories. So it's going to find all of the accessories that are greater than in price than the clothing. And here's an SQL statement using exists. And it's quite an interesting query. You can see that it gets pretty crazy. So let's look at the results real quick, and then we'll come back and look at this query. So the results, it returns any record that exists adhering to either subquery criteria. In other words, this query returns the customers for whom there exists some row in order details for a bike, and for which there also exists some row in order details for a helmet. So let's go back and look at this. It's running select all from orders, inner join order details on the order number in both tables, order details, inner join products on the product number in both tables, where product name like bike. And so we have our wildcard and bike, but notice there's no wildcard after bike. That's because we only want the ones that end with the word bike. And then and where customer ID equals customer ID in the order table and the customer table. So it's pulling all of the customers who have ordered a bike. Then it's going to also pull together all of the customers who have ordered a helmet. And again, we have the wild card and helmet and nothing after it. And it's pulling both of those, and notice that we're using the same tables in both queries, but because we're using the exists and exists, we don't have to rename the tables with, for instance, an O2. So here are all of the customers who ordered a bike and ordered a helmet. The uses for subqueries. Subqueries as column expressions. You can list vendors and a count of the products they sell. You can display products and the latest data, the product, or the latest date the product was ordered. You can list all staff members and the count of classes for each teacher. Uses for subqueries. Subqueries as column expressions. You could list vendors and a count of the products they sell, list products and the latest date the product was ordered, list all staff members and the count of classes each teaches. Subqueries as filters. You could list customers who ordered bikes using the N. You could display customers who ordered clothing or accessories using equal sum. Find all customers who ordered a bicycle but did not order a helmet. That would be not exists. What products have never been ordered? That would be not in. Show students who have an average score of 85 or better in art and who also have an average score of 85 or better in computer science. That would be using exists. And display students who have never withdrawn from a class, and that would be using not in. So this is subqueries.